Given, a zero-indexed integer array nums. Rule, build array ARR with the same length as nums. At each index I, look at every other index j where nums, j, equals nums, I. Sum the absolute distances I, j over those j. If there is no matching j, ARR, I, is 0. Return, the array ARR. Example 1, nums 1, 3, 1, 1, 2. At index 0 the value is 1, the other ones sit at indices 2 and 3, so distances 2 plus 3 make 5. Index 1 is the lone 3, so 0. Index 2 is 1 with partners at 0 and 3, 2 plus 1 is 3. Index 3 is 1 with partners at 0 and 2, 3 plus 1 is 4. Index 4 is the only 2, so 0. Output 5, 0, 3, 4, 0. Warm up with only two matching indices. Say they sit at index 0 and index 3 on the number line. Each one cares only about the other, and the gap is absolute 3 minus 0 equals 3. Different values never talk to each other. Add a third partner at index 5. If we brute force every pair inside the group, each new friend multiplies work. That is why we need a pattern instead of recounting every gap by hand. In the real array we first bucket indices by value, like a map from number to list of positions. After that we only solve one sorted list at a time, for example the ones at indices 0, 2, and 3. Next, let's establish the mathematical form of the left pass in closed form, then we'll sanity check it on a tiny example with the number line and the algebra on screen. At the current sorted position I, every earlier partner j sits to the left, so each gap is I minus j. Sorted order means we never flip that subtraction. Add every earlier gap, I minus j0, plus I minus j1, and so on. That is the full left contribution before we simplify it. Regroup the sum, I appears once for every earlier friend, so that is count times I. Then subtract j0 plus j1 and so on in one shot. That subtotal of earlier indices is running sum, meaning the sum of indices seen so far in this left pass. So left distance is count times I minus running sum. At I equals 3 the picture is two gaps, 3 minus 0 and 3 minus 2, which is 2 3's minus 0 plus 2, for in total. The right side is the mirror idea walking from the right, sum of later indices minus count times I, total distance at an index is left contribution plus right contribution. Repeat that recipe inside every value bucket. Solution uses 3 loops. First collect indices by value. Then for each bucket do a left pass and a right pass. Each pass is linear in that bucket. Loop 1 builds the hash map value to sorted index list. For our example, value 1 maps to indices 0, 2, and 3. Initialize left pass counters. Count left is 0, sum left is 0. Step I equals 0. Left is 0 times 0 minus 0, so add 0 to answer at index 0. Step I equals 2. Left is 1 times 2 minus 0, so add 2 to answer at index 2. Step I equals 3. Left is 2 times 3 minus 2, so add 4 to answer at index 3. Initialize right pass counters. Count right is 0, sum right is 0. Step I equals 3. Right is 0 minus 0 times 3, so answer at index 3 stays 4. Step I equals 2. Right is 3 minus 1 times 2, so add 1 and answer at index 2 becomes 3. Step I equals 0. Right is 5 minus 2 times 0, so add 5 and answer at index 0 becomes 5. Combining both passes gives final distances. Singleton buckets contribute 0, so the full answer becomes 5, 0, 3, 4, 0. Time is ON because we do one grouping scan, one left sweep, and one right sweep overall. Space is ON auxiliary for the hashmap buckets plus answer array, with only constant extra counters per pass. Define the function that returns the distance sum array. Build a hash map from each value to its sorted list of indices. Scan every index in the input once. Append this index into the list for its value. Prepare the answer array with zeros. Now process one value bucket at a time. Reset left pass counters for this bucket. Walk left to right inside this bucket. Add left contribution. Count left times I minus some left. Update left counters after using this index. Reset right pass counters for this bucket. Walk right to left inside this bucket. Add right contribution, sum right minus count right times I. Update right counters after using this index. Return the completed answer array.